So getting us into a couple of the applications, we're going to start by talking about orbits and weightlessness. So orbital motion, the concept of orbital motion is actually originally a Newtonian thought experiment. And his experiment, or his idea was, well, if I'm on Earth and I throw something, it follows this projectile path and it hits the ground. But what if I threw something high enough up, or from high enough up, fast enough that the shape of the projectile actually followed the radius of the Earth? So we're taking this concept right here and just zooming it out because we're going so fast. And this gets us into orbital motion. When we fire a projectile, the force of gravity pulls that projectile downward towards the center of the Earth. If I could launch it fast enough, which turns out to be right around 8,000 meters per second when we're at the Earth's surface, there becomes a point at which the curve of this projectile matches the curve of the Earth. And it becomes parallel to the Earth. We call this closed trajectory because it is a closed trajectory. As it goes all the way around, it comes back around to the original point. It's at the exact same point. So we call that an orbit. An orbit is the path that an object follows, or the trajectory of an object orbiting the Earth. And the concept is that there's actually always a weight force pulling it down. So something that's in orbit is actually constantly in free fall. So if we actually think back to the forces that are going on in this, then there is weight. Weight is the only force bringing it down, but that equals mv squared over r. So we have mg equals mv squared over r, or a is that that centripetal v squared over r, and that's the speed necessary to maintain orbit. And if we solve for that, we actually get the velocity of the orbit is the square root of gr. Now, this should actually look extremely familiar. We just said that this is the critical speed of someone who needs to make it around a half pipe. And if I think about it, a half pipe is essentially a type of orbit. It's just a little different. It's working on the inside of a loop versus the outside. So the velocity of the orbit is also the square root of gr. Now, an important thing to note, though, it says the velocity must be square root of gr. It can only be the square root of gr. If we're going too fast, we actually sling out. We're going too fast that our velocity is not brought back down by this weight force, and we will escape orbit. So there's some important implications that'll come up with that. So taking a look at Earth's surface, if we were to orbit directly at Earth's surface, we can go ahead and plug in g and the radius of Earth, and we get around 18,000 miles per hour, or 7,900 meters per second, at the Earth's surface. So that is directly at the Earth's surface and how fast you would have to go to orbit the Earth. We can also use this equation to calculate the period and how long it takes at any point around or outside of Earth's surface, so we can manipulate that radius and figure out how long it takes to orbit the Earth as well. So taking a look at that concept, the period of an orbit, currently right now, there are about 3,700 man-made satellites that are orbiting Earth. And out of that 3,700, 1,100 of them are active and 2,600 are inactive. Or they're in what they call in orbit. They're further away because they're just meant to sit there. It's called a graveyard orbit. And we'll take a look at a video that deals a little bit with satellites. A quick thought about why satellites are placed where they are. It's kind of interesting. Like, if you think about, if you're sitting on Earth, that's, sure, why not, that's Earth. And here's your country. That's not America, and there are you. Now, if you want to watch like satellite TV, there has to be a satellite. I don't know how to draw a satellite. There has to be a satellite orbiting Earth that can constantly send you electromagnetic waves to your satellite dish so that you can watch your HBO or whatever. So this satellite actually orbits then as it goes around and comes back around the Earth, it'll actually orbit with you. And that's a concept known as geostationary orbit. That means as the Earth rotates, the satellite orbits at the exact same velocity. So it's got to be some distance away from Earth, and this picture is starting to get just better and better. It's got to be some distance away from Earth that it's constantly in line of sight with you, and that's a huge application that's used all the time, known as geostationary orbit. So we're going to watch this video. It's a little bit about launching satellites, cool little video, and they'll also talk a little bit about the concept of what happens at the end of the satellite's life. This is an interesting video about SpaceX. SpaceX is essentially it's a company that puts satellites into orbit as like a service for hire, I guess you could say. And this particular object here, this is actually the launching mechanism that gets the satellite into orbit and with a fast enough velocity. And this whole video, this company has been working on re-landing these launch vessels so that they can be reused over and over again. So this is actually a sea platform. It's in the middle of the ocean, and it's designed to go and pick up the satellites. So this thing launches into space, essentially, and then does a controlled re-entry and comes back down so that it can be reused. So this company is a front runner in all this stuff right now. Nobody else is doing anything like it, and they're really popular, really interesting company. They're also the ones that are looking to plan that mission to Mars. So we could check this video out as well. This is actually, if you're bored, this is a full webcast that they did. The full process to launch a satellite. This is known from the Falcon 9, which was just another SpaceX, I believe, process of going through. So you can check out it is SpaceX. You can check out a full launch of a satellite and getting it into orbit from start to finish. This is an interesting little map of Earth's, or a graphic rendition of Earth's satellites. You see that we have all these satellites that are concentrated around Earth, and those satellites are in geostationary orbit. And then we have all these other ones all over the place. And some of these satellites are actually being used, but the vast majority of them are actually dead satellites that we just kind of launched off into space because we were done using them and they were running out of fuel. And these will all one day, since they're within Earth's gravitational pull, they will all one day go through this process known as orbital decay. So if I were to imagine this satellite right here, it's orbiting Earth, but it's as it encounters more drag, eventually it'll crash into Earth. Hopefully it'll burn up upon re-entry, but all these satellites, all 3,700 of them, one day will crash down to Earth. So got a quick check. Astronauts on the International Space Station are weightless because, well, the space station is orbiting Earth, so it is constantly in free fall around Earth. There's no normal force, so there's no apparent weight, and that's why they feel weightless, but they are constantly in free fall around Earth. Another interesting thing that SpaceX is working on is they're trying to do a mission to Mars. And that is a one-way ticket, but the concept is, settling on Mars, making it an inhabitable planet, because one day the Earth's already getting crowded in some areas, but so what's the next frontier? So SpaceX is actually working on getting a mission to Mars, and you can go and train and go to Mars. So if you're interested, go to Mars. This is an interesting little video about working out in space. If you actually ever go to space, especially, there are some people now analyzing whether or not a trip to Mars is possible for the human body. And one of the big things is because there's no gravitational force, your bones actually go through this decay process similar to osteoporosis, but in a much accelerated time. So this video is from Smarter Every Day. This guy gets to go check out a lab that deals with astronaut stuff. And if you look at this, it might not look like much to you. That's pee. that's urine. There's a lot of it in that one. This is all astronaut urine, and they do a burning chromatography process to analyze and understand what's actually being just wasted through your body as you're in space. And he also talks about how they work out in space to try to negate those concepts. But yeah, if you're in space, because of the lack of gravitational force, or you're always feeling weightless, your bones actually start to essentially break down and decompose as you're traveling. So you age terribly when you're in space. So if you're going all the way to Mars, you got to know how to fight that and how to have that that artificial gravity or some way that you can work out. So this video goes and talks about how you can work out in space. And that's actually all we're going to introduce right now. The next concept that we'll get into is talking about Newton's law of gravitation, which gets us further into the planetary talk, as you will. Astronomy is not actually within the scope and sequence of this class, but there are a couple of concepts that are. So we'll take a look at Newton's law of gravitation in the next segment.